Thank you very much, speakers. I'd just like to welcome you guys up onto the panel now for the Q&A session. I've had a look on the app and there is a number of questions there, so we'll try and get into that as quickly as we can. How does this come up on here? Let me get this thing to work. Might just have to grab my phone, I think, if it's not going to come up on here. Hang on, guys. So I think one of the first questions was for Lindsay. I'll just find it here. Lindsay, given increasing pressure on copper use in waterways, FSC, etc., what effort is going into exploring other chemicals? Obviously, yeah, for reading.
Okay, that's a good question, Sean.
No.
John, am I coming through? Yeah, I know. Good question. We have done a review of alternatives to copper. There's nothing really that's apparent for the foreseeable future. We will be looking at that. In parallel to that, we're initiating research or considering research on the environmental impacts of copper and doing more work on that. We have done some work on determining how much copper gets into the waterways. The next stage of that would be looking at the effect of copper on aquatic organisms and the little bit of copper that gets into the waterways, is it actually affecting the organisms or not? So we're considering starting some research on that to just determine the environmental effects of copper in water.
Thanks, Lindsay. Natalie, next question. What is the physiological mechanism that allows some families of radiata pine to resist Phytophthora needle blight and Dothystroma needle blight? And I see there's also a question there related to red needle cast as well. So,
the quick answer to that one is no, we don't. We're not interested at this stage. From a breeding perspective, we haven't been chasing the underlying mechanism. We're more interested in just finding it. It'd be great if we could find some genetic markers that tag to those traits, but we haven't been pursuing the actual underlying mechanism at this stage.
Okay. Thank you. Done that question. All right. Okay, given the ability of Phytophthora to adapt and change, is reliance on breeding enough? Is it maybe you, Natalie, again?
We've got to start somewhere, and as Rebecca's work has shown, we look like we've been limited to 2 introductions at this stage, so you'd imagine that the diversity that's out there is pretty narrow. If we start to get a lot more introductions, the first step, have a chat with biosecurity, and we can only plan for what we've got at the moment, and it doesn't. Based on the resistance profiles that we're seeing, it doesn't look like we're going to have the basis of our resistance is not going to be a single gene. It is going to be a quantitative resistance, and those types of resistance are generally harder to overcome anyway.
I think it also highlights the importance of maintaining genetic diversity, and you can have clonal forestry, but you wouldn't want to rely on just 1 or 2 clones. You want to adopt several and keep that rolling over.
If I may, there's also work going on looking at potential for virus for control of Phytophthora and even using viruses as expression of transgenes. So there are other options that may come up to combine with breeding.
Okay. Next question. On the sites where trichoderma has been trialled, was the soil tested prior to planting for the presence of trichoderma? Will it be present in soils in some places without inoculation? Helen.
Yes, trichoderma is, because it's a natural fungi found in the soil, it's present everywhere, it's out the window in all of our forests, but at varying levels. Generally it's quite low. And in some of the trials we are starting to test the background trichoderma, so we've got a good feel for that. But if you can put in inoculated trees, you're putting in these trichoderma strains that have been selected to give benefits, so it's like you're adding another layer on top.
Okay,
Yep.
thanks. Just pretty much answered that one.
Yeah, well, all of the trichodermas that we're working with are native, if you like, native New Zealand trichodermas. We've just gone through the process of selecting the more beneficial ones, because out in the natural environment you've got a whole range of different species. Some are beneficial and some aren't, and by going through the selection process we've come out with the better ones, and chances are there'll be even more superb ones out there. It's just finding them. It's a big process to find them in the first place. So yes, there will be better ones as well, but there's only so much you can do.
Thanks, Alan. These questions are jumping up and down a bit here, and we've answered that one around the mechanism for red needle cast. So I'll jump on to the next one. Lindsay, is the red needle cast outbreak model available for public use? Can it be set up to report on times of high or low red needle cast, a la fire danger website?
Yeah, that's a good idea. It's not available for public use yet. I don't think it's quite ready yet, but obviously the intention is to make it for public use when we are confident that it's ready for that. And maybe a mechanism is the Dothers Stroma Control Committee or something like that, some other forum.
Okay. Just check on the floor. Has anyone got any questions out on the floor there that they want to ask? Oh, Brian, over the back.
Yeah, there's something I don't think I quite understood a couple of points. So one was looking at the epidemiology of Cludialis, and you're saying that the primary infection is a 2-day process and then the secondary 22 days. Then in the modelling, we're seeing that the strong correlation, strong prediction of outbreak is based on factors 3 months prior, 3 to 6 months prior to that event. I'm just trying to marry those two pieces.
So for the model, the 3 to 6 months correlation that we observe is actually based on visual inspection on the field observations. So there is still like some time for the pathogen to actually express itself.
Yeah, and good point, Brian. I don't know the answer to the question about why lesions first develop 5 days after inoculation, but then the secondary infection takes another 18 days. I don't know the answer to that.
Yeah, it's really that big gap. It's occurring 3 months prior.
Yeah.
I mean,
Why would we see it anyway?
Yeah.
is it possible, I'm just speculating, that it's something to do with the tree itself rather than the pathogen, and perhaps there are events 3 to 6 months in the history of the tree that predispose it to infection when the pathogen actually turns up, rather than those 3 to 6 months driving necessarily what's happening in the pathogen, but it's rather driving what's happening in the host. Just a guess.
Had another hand up there, just John, from the floor again.
Yeah, question for Helen. Given that we use copper as a fungicide out in the forest, is there a potential, or is there the potential to actually negatively impact on trichoderma that we're trying to introduce?
Yeah, I'm just starting to do some work on that. What is the impact of, in this, mainly concentrating on nursery chemicals, but copper will be included as well. There'll be quite an intimate contact of trichoderma in the chemicals, so it's a slightly unfair test, but it'll give us a bit of a feel for how sensitive trichoderma is. In the literature, it tends to be relatively tolerant to many chemicals, so I think we'll be able to sort through issues if there is potential clash with chemicals and the natural organism.
Okay, I'll just go back to the poll again, the app. Rebecca, what was the chemical analysis done by NMR, and how were the chemicals isolated from the tissue to be analysed? Can the different chemicals be isolated and identified using GCMS? Which you might want to explain some of those things.
Okay, so first of all, I'll do my best to answer this question, but the work was actually done by Laura Raymond and Stefan Hill, and I just had the pleasure of showing their slides. I think we've used NMR. NMR was used with the Cody tissue culture. That was the first slide that we presented. And GCMS has been used, I think, maybe with the pine tissues at the end. So in terms of how the chemicals were isolated, that was actually a really large part of the metabolomics work stream that happened during the Healthy Trees project. It actually took quite a lot of time to perfect those methods. So while I'm not an expert on what was actually done, I do know that that was a significant part of the program and is one of really the key enabling technologies that came out of the work.
Thanks, Rebecca. I'll probably just got time for one more quick question. Again, it's a Lindsay one. Lindsay, could an explanation for the high levels of Phytophthora in New Zealand versus the native host range in Oregon be because there are other native endophytes competing and therefore protecting the trees in Oregon that are not present in the population here?
That is one explanation that has been offered. We will do some work on that. We haven't started that yet. It's plausible. I'm not saying yay or nay.
Okay. That's a quick answer. There we go. I might see if we've got one more that we can quickly answer there as well. Okay, Lindsay, unfortunately genetics won't be the answer for the next 30 years, so can you give us an idea of the cost benefit of spraying for control over red needle cast over the longer term?
Cost benefit for spraying is pretty simple really. You need to increase growth and get the revenue from that to cover the cost of the spray. So it's a pretty simple equation, really. I think licence to operate is a bigger risk for duration of spraying rather than the economics of it. And as I say, that's why we're doing some environmental work as well to support any movement towards the banning of copper and the like.
I'll just add a piece there. There's also a couple of significant trials that were put in the last 12 months looking at that very question for sort of medium to long-term trials. Yeah. Okay, guys, I'd like to just wrap up the session for this morning. I'd like to thank our panel, and obviously it's time for morning tea, so if you can just give a round of applause to everyone. Thank you very much.